Hi folks, happy Wednesday. Sorry I can't be there today. So today's video is about integrating by using partial fraction decomposition. That is a pre-calculus learning objective. It's something hopefully you should have learned last year, but we are all a little rusty, so we're going to do a little bit of review first. So to start off with partial fraction decomposition, really where it stems from is when we have the integral of 1 over x squared minus 7x plus 12 with respect to x, we're asking ourselves, how do we evaluate this? What is it equal to? We cannot use u sub. That doesn't work. By parts doesn't work. And the good old fundamental theorem of calculus, just taking the antiderivative, also does not work because natural log of x squared minus 7x plus 12, well, then we need to do chain rule, and then we get quotient rule, and that's just no good. So what we want to do is we want to break this fraction into two pieces so that we can actually end up using the fundamental theorem of calculus. So how do we do that? Just a quick aside, if I were to ask you to simplify 1 over x minus 4 plus 1 over x minus 3, the answer I would hear from you is common denominator. And so we do that by multiplying this by x minus 3 over x minus 3 and x minus 4 over x minus 4. So we have x minus 3 plus x minus 4 all over x minus 3 times x minus 4, which we can simplify to 2x and then minus 3 minus 4 minus 7 over x minus 3 times x minus 4. So that is simplifying two separate fractions. Partial fractions is sort of reversing the process. So here's where you want to start taking notes if partial fractions is something that you do not remember. So we're going to do this with the integral of 1 over x squared minus 7x plus 12 with respect to x. How do we evaluate this integral? I'm going to teach you two methods. I believe you definitely learned method 1. Based off of today's lesson in block 3, method 2 seemed to be familiar to some and not to others, so regardless, you get two methods, you get to choose which one you like. So if we want to reverse the process of like simplifying and instead go from one fraction into two, the first option you have, I'm going to call it method 1, set coefficients equal. And so that's just the beautiful name it's being given. So what we're going to do is we're going to take 1 over x squared minus 7x plus 12, and we are going to, the very first step in all partial fractions problems is to rewrite your denominator and to factor it. 1 over x minus 3, x minus 4. And what partial fractions tells us is that this right here can be written in the form of some number over x minus 3 plus some number over x minus 4, similar to what we saw above. We can split that up into two fractions, but we need to figure out what is A, what is B. That makes this equal sign true. So how do we do that? Well, in method number 1, which is set coefficients equal to each other, our next step is to multiply both sides of this equation by x minus 3 times x minus 4 to just get rid of those denominators. So what's left on the the left-hand side is just 1. When we multiply a over x minus 3 times x minus 3 times x minus 4, we are left with just, sorry, I'm struggling to write, a times x minus 4 plus b times x minus 3. I'm gonna do a quick pause for you to check that, yep, that makes sense. Okay, so our next step is, now that we have this, we're going to distribute the a's and the b's, and we'll have 1 is equal to ax plus, minus 4a plus bx minus 3b. And based off of the left-hand side, that 1 is a number, it's a constant. So 1 should equal minus 4a minus 3b because there's no variables there. So we can set our coefficients equal. 1 is equal to negative 4a minus 3b. And now our other variable, we have two variables, a and b, so we need another equation. And we know that ax and bx, well, this is a hidden plus 0x right here. So 0x is what ax plus bx should equal. Now we want to go back to our good old Algebra 1 skills and substitute. So basically, the x's can be factored out. So 0 is equal to a plus b. That means that a should be the opposite of b. Plug this into our other equation. We get 1 is equal to negative 4 times negative b minus 3b. 1 is equal to 4b minus 3b. 1 is equal to b. Great. That means when we plug this back in here, that means that a is equal to negative 1. So we've found our numerators. And something that we have to be careful with is making sure that a, this negative 1, goes over the fraction that has x minus 3 in the denominator. So just check to make sure, okay, a, yep. And then plus b was 1 over x minus 4. Okay, so that is how we decomposed the original 1 over x squared minus 7x plus 12 into two separate fractions. Before we move on to evaluating the integral with this, we're going to look at method number 2. Before we do, I'm just gonna pause for a couple of seconds, give you some time to think, write down any questions you have, things you're unsure about, or if you think I made an arithmetic mistake somewhere, check me. It is the end of the day, so my brain is a little tired. Okay, hopefully you have jotted down any questions or ideas you have, because we are going to move on to method number 2. So method number 2 says something very similar. In fact, it's so similar, we are going to start in the exact same spot that we did with method number 1. Method 2, we're going to call this plug in x values to eliminate terms. So this is method number 2. And in method number 2, we still have 1 over x squared minus 7x plus 12. We still want to factor our denominator. And our goal is still to break this into two fractions with some numbers on the numerators. And just like in method number 1, we are going to get rid of those denominators by multiplying both sides by x minus 3 times x minus 4. But after we do that, things go differently. So we have 1 equals a times x minus 4 plus b times x minus 3. So here is where things go differently, because instead of expanding and then setting up two equations and substituting and then plugging back in, what we're going to do is we're going to say, is like, wouldn't it be nice if this term just wasn't there, so that we could have like something equals just b and we could figure out what b is? Well, we want to plug in an x value to eliminate this term. So what makes this term become 0? X equals 4. So when x equals 4, we have 1 equals a times 4 minus 4 plus b times 4 minus 3. This is 0. 1 is equal to 4 minus 3 is 1. 1 is equal to b. Done for b. Now we need to get rid of this other term to find a. So our next step is, well, what value of x makes this term become 0? When x equals 3. Then we have 1 equals a times 3 minus 4 plus b times 3 minus 3. 1 is equal to 3 minus 4 is negative 1. So this is going to be negative a. This becomes 0. 1 is equal to negative a, so negative 1 equals a. Hooray! And if you'll notice now, actually, we get the same b value and the same a value as we did in method 1. And that is not a coincidence. They should receive or wind up with the same a and b values. And so this tells us that our partial fraction decomposition is negative 1 over x minus 3 plus 1 over x minus 4. So that is a method you can use if you have not learned this method yet. Now you know it. You're welcome to use it. If you like method 1 first, feel free to keep using it. If you like method 1 better, feel free to keep using it. Okay, but that is all pre-calculus. What we need to do is calculus. Our original question was actually, what is the integral of 1 over x squared minus 7x plus 12 with respect to x? And so what we need to do is, now that we've broken it into two fractions, no matter what method we used, we will have these two fractions. This is more manageable than before. So our integration properties tells us we can split this into two integrals, and I'm going to pull that negative sign out in front. Negative the integral of 1 over x minus 3 dx plus the integral of 1 over x minus 4 dx. Now here we know that the integral of 1 over some number dx, that is going to be natural log of that blob as long as the blob's derivative, so blob prime, equals 1. So check, does this derivative equal 1? Yep. So we have negative natural log x minus 3 plus our first constant. Again, we have another 1 over blob. Is the derivative of x minus 4 1? Yep, so this is plus natural log of x minus 4 plus a different constant. I'm calling this C1 and C2 because they're probably different numbers. Really, C and C. So when we have them together, we have negative natural log of x minus 3 plus natural log of x minus 4 plus, well, what's a number plus another number? Just another number. So plus C at the very end. If you wanted to note this C3, you're welcome to. You do not need to. A question was asked that, ta-da, am I done? In your pre-calc class, the answer was probably no. You need to use your log properties to restructure this. So my response to that question is, on my tests, this is fine. This is a fine answer. On the AP test, this is going to show up in a multiple choice question. And since it's a multiple choice question, the answer will most likely be in the form of, well, this is really negative natural log of x minus 4 minus natural log of x minus 3 plus c. you need to use, when you subtract two natural logs, you're dividing x minus 4 over x minus 3 plus c. This is the answer choice you will see on multiple choice for the AP test. Very rarely will they have it all line out like this, so knowing your log properties is important. You might be annoyed, but that's life. Okay, I'm gonna pause so that you can write down any questions, clarifications, comments you have. Please write those down now so that when you fill out the survey at the end of this video, I can help plan Friday's lesson. Okay, so what I'm going to do now is I'm going to give you your 4 partial fractions practice questions. So here's one. I would like you to integrate 5x minus 3 all over x squared minus 2x minus 3 with respect to x. That's the first one that you'll do. Second one, two x plus 2 over x minus 3, x plus 1. The third integral that you will do is x squared minus x plus 2 over x squared plus x minus 2 with respect to x. And the very last one, 1 over x squared minus 1 with respect to x. So, whoa, been in my classroom for too long. About these, some notes is that restructure algebraically first. If you can simplify without using partial fractions, and you don't have to use partial fractions to integrate, don't use partial fractions to integrate. The second thing is long division may be needed. So think about those 2 hints. If you have questions about these 4, please ask. I'll hopefully be there after school today, and email me about meeting during lunch on Thursday or during 7th, the second half, Friday during lunch. Come and talk. Just let me know what you need. And please fill out that Google form. You are trying these problems 1, 2, 3, 4 first, then fill out Google form. Please. Many thank yous. Have a great rest of your Wednesday, and I will see you on Friday.